All right, now time to talk about that gray area. These are resources that aren't considered renewable, meaning that eventually we could run out of these. When they're done, when we're done with them, they're done. Like they don't replenish themselves, but they also don't actually have a direct carbon footprint, or they don't have a major carbon footprint in terms of their use. So unlike burning coal, which releases carbon dioxide, or burning natural gas, which releases carbon dioxide, these actually, they don't, in their active process, they don't actually release carbon dioxide or methane or greenhouse gases. And there are two main ones. There's nuclear energy and hydroelectric energy. So first, let's talk about nuclear energy. So nuclear energy sounds like it is super complicated. And one of the reasons why it's super complicated is because there's a lot that goes into it. But the actual process of generating electricity is not that difficult. So here's how it works. You have what's called a nuclear reactor. A nuclear reactor, let me actually put this up before I explain how this works. So first off, it's non-renewable. There are some downsides, obviously, mostly issues with what happens if containment is breached. And we've seen incidents of that before. 3 Mile Island, Fukushima, and then obviously the big one, Chernobyl. There was a whole TV series done on it. But let's actually talk about those really quickly. So let's actually talk about how it works. So here's how it works. You have a series of fuel rods, and these rods are made up of some kind of radioactive, some kind of unstable material. Usually things like plutonium or uranium are used. And basically the way that it works is that when these things are brought into the reactor, they're initially not active, meaning that there is not active nuclear fission, basically the splitting up of atoms, happening in them. And then what happens is, through a process, neutrons are fired at these rods, at these fuel rods, which then make them start to split atoms up. Well, when atoms are split up, when this process occurs, it releases a lot of energy in the form of heat. Not only that, but that also causes these fuel rods to get really, really hot, and their surroundings to get really, really hot. So in order to prevent them from melting, reaching their melting point, and in order to produce a lot of energy, we take these really, really hot fuel rods and we keep them submerged in water. Well, what happens is, as that water is interacting with the fuel rods, that causes it to boil. That produces a lot of steam. That steam then rises to the top of the reactor. Then through a series of pipes, that steam makes its way over to a turbine, and it turns that turbine. That turbine is then attached to a generator, which then generates electricity. That electricity is then fed into a grid and off to your house. After that steam goes through that turbine, it is then taken into a condenser where liquid water from somewhere else, cooler water, usually from a river or from a stream or from something like that, cooler water is actually pumped in, and it interacts with that steam to cool it down, to cool it to condensation levels. And then it condenses back into liquid water, feeds back into the reactor, and it's an entirely enclosed system. And one of the things that they do in order to make sure that it's closed is that the water that they're pumping in, that cooling water that they're pumping in, is actually water that is completely isolated from the reactor water. It's enclosed in a set of pipes that are completely contained from the reactor water. So this cooling water pumps in, it cools the steam down, and then it's pumped back out, and it's released back into the river or to the lake or to the whatever. Usually it's at a higher temperature at that point because in order for it to cool the steam down, it had to take some heat from the steam. That's really the big byproduct of a well-functioning nuclear reactor. A well-functioning nuclear reactor. So when it's contained and when this process is working seamlessly, it's actually a really good thing. This is actually a nice, really good system. Here's the problem though. All of this relies on containment structures that might be vulnerable. So if something prevents the water, that condensed water, from pumping into the reactor, what that will actually do is that'll actually stop this whole process, and that could actually cause the control rods to melt. Those control rods then melt, they pull down at the bottom of the reactor, they may melt the bottom of the reactor and then sink down beneath it. That's what a nuclear meltdown is. So a nuclear meltdown isn't like a big explosion. Now, explosions do happen because in this same process, steam will actually build up in the reactor. What actually happens is steam takes up a lot more space than liquid water does. Well, when all of this liquid water, when now there's no cool liquid water moving, the condensers aren't working anymore, all of that liquid water converts into steam. That steam then builds up inside the reactor, and steam has a very high pressure to it. So as more steam builds up, more pressure builds up. At some point, the pressure becomes too great, and kaboom! You end up getting a steam explosion out of the reactor, and then that could actually fill up the containment structure, and then boom, that can explode as well. And that's actually what happened at Chernobyl. There was a steam explosion. That's what happened at Fukushima. There was a steam explosion. And so all of this radioactive water, this radioactive steam, is now shooting outwards. So obviously nuclear power, if it's not done right, can have some major, major drawbacks. It can have some major drawbacks, but it is this hot fuel rods that form or that become hot via nuclear fission, the splitting up of atoms, heating water, causing it to turn turbines, then cooling back down and going back into the system. It is this self-contained structure, not self-contained, but it is this contained structure that actually causes all of this to work. But if something breaks, all of that stuff gets out, and all of a sudden, everybody's turned into the Incredible Hulk or died of cancer. Not fun. So containment is key. Containment is key. If we lose containment, all of that nuclear steam gets out, and that causes all kinds of problems. Another problem is those fuel rods only have a certain amount of use to them. That's why it's not considered renewable. Eventually, those fuel rods, those atoms that are splitting, you're going to run out of atoms to split, or you're going to run out of atoms that are unstable enough to split. What's left behind is an unusable, but still highly radioactive and highly toxic fuel rod. So it's highly radioactive, highly toxic, but it can't be used in electricity generation anymore. What do we do with that? We can't just throw it outside. It's radioactive. It's going to contaminate everything. Well, what has been done right now is many of these plants have temporary storage facilities where they put these used fuel rods, and there are actually permanent facilities that are being built. And there's actually a whole cool video. Maybe I'll link it in the description from Wendover Productions. If you've never watched Wendover Productions before, it is really awesome. about what to do with those fuel rods. And then, yeah, what happens when something goes wrong? In the Fukushima Daiichi incident that was in 2011, right after that massive tsunami, the tsunami actually knocked out their power generation capabilities. That actually stopped the flow of water into the nuclear reactor, causing the water that was in there to completely evaporate, building up steam, and then boom, big steam explosion happened. And that is all radioactive steam. And then Chernobyl, there are whole documentaries on the Chernobyl explosion. I've actually really geeked out over watching some of them. Basically, what it was some people in the middle of the night were running a test that they were mandated to run. They were not experts. And something went wrong, and the wrong people were there to fix it. And that ended up being a whole mess. That's what happened in Chernobyl. And then there was the 3 Mile Island incident. So nuclear actually is very controversial because of this. Not everybody's fully on board with nuclear. Not everybody's fully against it either. And in fact, in this week's module activity, I'm going to have you develop your own opinion by watching a few Kurzgesagt, that's always hard to pronounce, videos on YouTube. There's actually a new one that came out the same week that I recorded this, and I'm actually going to throw that one in there as well. And kind of come up with your own opinion about nuclear power generation. Okay, hydroelectric power. Now, hydroelectric power doesn't have the same toxic byproducts of nuclear power, but it is also not considered renewable because, especially in these last 10 years, rain has been a lot less reliable here in California. And so our rivers have been lower, our reservoirs have been lower, our ability to harness hydroelectricity has been a lot lower. Furthermore, there's also some controversy behind the idea that in these dams, you may get a lot of bacteria and a lot of algae that actually produce and release methane. That may actually have a bad carbon impact on it. That is a little bit more unsubstantiated than the idea that this is water dependent, this is rainfall dependent and snowfall dependent. And really the way that this process works is you have a reservoir that's full of water, and then you have a dam. You have a dam and dam. And what happens is water funnels into that dam. As it's funneling into that dam, it's turning a series of turbines. Those turbines then turn a generator, and that generator produces electricity, which then gets fed into the electricity grid. And then the water, after it turns the turbines, it channels into a river below, and that's that. So one of the biggest negatives of this is that dams can break. And when you have all of this water contained behind a dam, and if something happens, either structural failure, or maybe we have a situation where there's more water coming in than can go out, the dam can actually break and overflow, and all of that water suddenly rushes out into the much smaller river below. And usually downstream of these rivers, there are homes. So the breaking of dams is actually a big concern, as well as I mentioned, rainfall, especially here in the Western United States, has become a lot less reliable. And then that potential carbon impact of the reservoir itself might be of concern. That one, once again, is a little bit more unsubstantiated. So that's nuclear and hydroelectric power. Next, we're going to talk about renewables.